If you recall, when we defined center of mass, okay, let's see, the equation was, or the definition was, the center of mass is the average position of the mass. And we wrote it as an average equation where it is m1x1 plus m2x2 plus etc. over the sum of the masses. And we can apply that for each of the directions. Now, the same applies to something different. That's called the center of gravity. That's the average position of the gravitational force. In most cases, with objects that we deal with at the surface of the Earth, center of mass or center of gravity is the same thing. But if you notice what we mean by center of gravity, look at the force. We are writing Fg at position x1, and then Fg at position x2, and so on. Fg, if you recall, is m times small g. That's when we are at the surface of the Earth. So if we have here m times g for each one of these Fg's, the g's will cancel out. So in general, the center of gravity and center of mass are the same. Let me correct. At the surface of the Earth, the center of mass and center of gravity are essentially the same. However, when you start talking of gravitational scales, this does not hold anymore. Let's take this as an example. And the pictures here are not to scale. We have the Earth and the Moon. Okay, consider the gravitational force that the Moon is going to exert on 1 kilogram of Earth here. And consider the gravitational force that the Moon is going to exert on 1 kilogram Earth here, on the other side of the Earth. Now, for the first one, the gravitational force, we have to use the more general expression. Remember what that expression is. So gravitational of Moon on 1 kilogram nearby, so I'm going to write it as small m. That's going to be capital G, the universal gravitational constant, mass of the Moon times the 1 kilogram over the distance separating the Moon from that 1 kilogram. And that distance is this much. Now, for the kilogram that's far away, gravitational Moon on far away, so I'm going to write F, is G, mass of the Moon, 1 kilogram over d2, now squared. But d2 in this case is this distance. And the distances are quite different in this case. They're not the same. Quite different because the Earth is quite a sizable object. If we were to calculate these, and I'm not doing it in this particular case, we'll find that the values, this one and this one, are going to be different to about 7%. The difference between them is about 7%, which is not a small number. The difference is what causes high and low tides. That's the water here is being pulled with a slightly stronger force than the water here. That's why we are going to have a high tide here and a low tide in the opposite side. Actually, it's high tide in both sides, I'm sorry. the water here is being pulled with a slightly stronger force than the water here. That's why we get the high tide at this area here, low tides at the perpendicular positions here and here. Now, the opposite happens. The opposite happens when we think of the forces acting on the moon. Consider 1 kilogram of moon surface here and 1 kilogram of moon surface here. The nearby moon surface, this is going to be d1, and my equation is going to be the same, except here it's going to be mass of the Earth, and of course the appropriate d1. Now, for the other one, this is my d2. And then, of course, we said this is Earth. The difference is not as drastic in this case. It's about 2% different. But it is the reason why we have one end of the moon locked towards us. It is the reason why we see only one face of the moon from the surface of the Earth. We see that one face because the average force on the moon is off the center of mass. So when it is off the center of mass, if this is my center of mass, I'm exerting a force off of it, so I'm kind of pulling that end towards the Earth, and that's what prevents it from rotating about itself. And that's why we see only one side of the moon. So the effect of the difference in center of gravity results in tides at the surface of the Earth, and it results on us seeing only one side of the moon when we talk of the moon.